Okay, so this is the review sheet for your SIIP test. So number one, I see that I have a graph here, and it says that the title of the graph is dog data. So here is the mass of the dog, and then down here is the years. What is the independent variable? This is my independent variable. If I'm independent, I have an ex-boyfriend or girlfriend, so this is my independent here. So it's year. The dependent variable is then the mass. What is a hypothesis for this graph? It would be an if-then statement. So it would be if the years go on, then the mass will go up, will increase. Does the relationship between variables remain the same? No, or not. If they remain the same, this would have continued to go up. So no, because the graph goes up, then down. Okay, number two, incoming solar radiation. Reflected by the atmosphere, 30%, absorbed 20%, absorbed by the Earth's surface, 50%. So a pie chart shows my percentages. So I would have 50% would be here. So this would be absorbed by Earth's surface. And then I would have, let's see, this would be about 20, and this would be my 30, so this would be my 20%. This would be my 30%. And this is my reflected. And this is absorbed. And I could also color code it. And I could just color it. Number three, the effects of NaCl solute on boiling point. So here I have my grams of NaCl, the boiling point. So I can look at this and I can see that my grams increase, and as my grams of salt increase, the boiling point is decreasing. So my independent variable is my solute amount, which is my grams of NaCl. The dependent variable is my boiling point. What is their relationship? So as this increases, so as grams of NaCl increase, the boiling point decreases. Okay, so number 4. Complete a line graph using the data above. Show distance traveled and time. Okay, I don't have a lot of space. So let me complete this here. So I'm looking at my bike ride summary. So I would have my distance is going to be my dependent variable. And it goes from 0 to 6, but it's over time. So I'm going to go 0, and I'm going to go, let's say, 3, 6, 9, 12, 15, and this is going to be in kilometers. And then my time is at 15-minute increments. So I have 0, 15, 30, 45, and 60, because it says a complete at 60. So my first part of my ride, I go 6 miles. So I start here at 0, and I go up my first 15 minutes, I go for 6 miles. My first part, I go for 6 miles, and it takes me 15 minutes. My second section, I'm not going to go at all. So this is going to be my rest point. So here, I'm going to stay exactly where I am. So I'm going to have a flat line. And then my next section, my third section, I go for 3 miles. So I just go a little bit for my 45 minutes. And then my fourth section, I just go 1 mile. So I'm just going to go teeny little bit up for my next 15 minutes. So my graph would look something like that. Oh, there's my graph. I should have done it there. Okay, how would you explain how much to find how much the temperature increased? Explain how you would find how much the temperature decreased. Okay, so here I'm looking at my temperature in Celsius and my time in minutes. So how would you explain how you would find how much the temperature increased? So if I'm looking at my cold cup, I would about here. So this is 20, 40, 60. So this is probably 22. So I would go 22 degrees Celsius, and then over time, over 20 minutes, it made to 22, 24, 26, 28. I'd say 30 to 30 degrees. So it increased, so I would subtract final from my initial. So I would go 30 minus 22, and then I would have an increase of 8. Explain how you would find how much the temperature decreased. So here I'm just a little bit below 100. So I would subtract here, I would subtract my final from the initial. So I would have 100, let's see, maybe 98 minus 62, 64, 66. 32 degrees. And I think I made a mistake on this. So here, how would you subtract my final? It's the opposite. I would subtract my initial from my final on this one. So I'm subtracting my initial from my final, and here, sorry, said it again. Yeah. And then here, I'm subtracting the final from the initial.